Bismillah ar-Rahman ar-Rahim. So here let's solve an example of a previous exam for the lab. The first question, the length of the box A is, this is box A and this is the ruler. In these kind of questions, we start first with the error. So by definition, the error is the smallest division. So what's the smallest division here? It's 1 centimeter. So I start with the error. It is 1. Now the length of the box start from the 0 and end up between 4 and 5. Between 4 and 5. I cannot put 4.5 or 4.8 or 4.7. Why? Because that's the second rule. Number has to match the error in accuracy. So it is between 5. If I put 4, it's correct. Or if I put 5, it's also correct. However, in the exam, you need to choose an answer. You cannot put 4 and 5. You have to put either of them. 4.8 or 4.7 is wrong because it has accuracy more than the error. Second question, how many significant figures does each of the following numbers have? So this is 3. This is only 2 because if you have a decimal, 0 will be counted only after a non-zero digit. So this 0 does not count, this 0 does not count, so it's 2. This one is 1. And this one is 1, 2, 3, 4. Calculate the following respecting significant figures rule. So what's the significant figure rule in multiplication or division? Always we go for the smallest number of significant figures. So first let's do the numbers using calculator. So 88,000 multiplied by 4040. So that's the number you see in the calculator. Now I need to decide how many significant figures. Well, this number has 2. This number has 4. So the answer should have only 2 significant figures. 2 significant figures. That means I will have 3 and 6, and the rest I need to truncate. However, I cannot write 36 only because that's too small for the number. So I need to put how many zeros? 1, 2, 3, 4, 5, 6, 7 zeros. So I put 7 zeros. 1, 2, 3, 4, 5, 6, 7. Or if you know how to write it using exponent, 36 of course, 10 to the power 7, 7 zeros. Let's do the second one. It is 625.7 divided by 3. So that's the answer. See in the calculator. However, this is 4 significant digits. This is 1 significant digit. The final result has to be 1 significant digit. 1 significant digit. So I just write 2. And then this is too small. I need to add 2 zeros. So it's a 200. It's a 200. If you write the answer using the numbers from the calculator, for sure it is wrong. You need to apply significant figures rules. Now the attached table shows the data for a given measurement. Calculate and present the mean value with uncertainty. So this is standard deviation. We measured 4 times. We find the average, and from the after we find the average, we find the standard deviation, and after the standard deviation, we find the error. So I did the same example in the error and measurements with 3 numbers. So we apply the same rule, but now for 4 numbers. So I will just start the solution, and then I advise you to look at the video for error and measurement, and there is a complete example to do this kind of error calculation. So here x average will be 10 plus 9 plus 11 plus 10 divided by 4. We keep all the digits. We don't round them unless we calculate the error. And then we find standard deviation. What's the answer here? So 10 plus 9 plus 11 plus 10 divided by 4, so that is 32. No, it's 10. It's 10. 10 plus 10 plus 11 plus 9, that's 40 divided by 4, that is 10. So I just write 10. So standard deviation will be 10 minus 10 square plus 10 minus 9 square plus, very easy example by the way, very easy exam, minus 11 square plus 10 minus 10 square, everything under square root, and then I divide the 4 minus 1 divided by 4 minus 1. So as you can see, it's a very easy example. 10 minus 10, 0. Here I have 1 and 0. So it is basically it's 2 over 3 under square root. Take square root. So it is, I keep also standard deviation, I keep all the numbers. I mean, not all of them, but I don't do any rounding. 6, 4, 9, 7. That's the standard deviation. And then I calculate the error, which is 0.8165, let's say, divided by square root of 3.